Hi, I'm Belém Calderon.
And I'm Cheyenne Delicate.
And I'm Keith Perez, and we're going to be talking about rational functions and asymptotes.
I will be telling you guys how to find the domain of rational functions.
And I will be showing how to find horizontal and vertical asymptotes and how to graph the rational functions.
And then I'll end off with an example in order to recap.
To find the horizontal asymptotes, you will first look at the degrees of the exponents in the numerator and denominator. If the numerator and denominator have the same highest exponents, then it's a ratio of the two coefficients. So our problem is 3x cubed plus 7x squared plus 2 over negative 4x cubed plus 5. And step 1 is finding the horizontal asymptotes. So you would just take the numerator and denominator, which is 3x cubed over negative 4x cubed, to find the horizontal asymptote, and the x cubed plus and the x cubed in the bottom will cancel out, and your horizontal asymptote will be negative 3 over 4. So step 2 is finding the domain. To find the domain, you just set your denominator not equaling to 0, which is negative 4x cubed plus 5, and you just not equal it to 0. And by doing that, you subtract 5 from both sides, which gives you negative 4x cubed not equaling to negative 5. Then you divide by negative 4 on both sides. Then you get the cube root of x squared not equaling to the cube root of 5/4. And you will get x not equaling to 3, the cube root of 5/4, and since it cancels out, and your domain will be negative infinity to the cube root of 5/4 union to cube root of 5/4 to infinity. So step 3 is finding the y-intercept. So our y-intercept is 0, 2, and you just basically replace the 2 for the x in the problem. So you have 3 parentheses 2 cubed plus 7 parentheses 2 squared plus 2 over negative 4 parentheses 2 cubed plus 5. And you basically just solve for it, and your final answer is negative 2. So step 4 is just graphing the problem out. Since our horizontal asymptote is negative 3/4, you mark it there, and you have the 5 over 4 vertical, and you mark it there, and you just basically draw your arrows where they belong. So
So the definition of vertical and horizontal asymptotes is that the line x equals a is a vertical asymptote of the graph of f if f of x is infinity, or f of x is negative infinity, as x is to a either from the right or from the left. The line at y equals b is a horizontal asymptote of the graph of f if f of x to b as x to infinity or x to negative infinity. So our equation is f of x equals x squared plus x minus 2 over x squared minus x minus 6. So the first step is to solve this, and we're going to factor the numerator and the denominator out, which would give you x minus 1 parentheses x plus 2 over parentheses x plus 2 parentheses x minus 3, and then the x plus 2's would cancel out, and it would leave you with x minus 1 over x minus 3, and x cannot equal 2. Okay, so for step 2, we're going to find the vertical asymptote. And to do this, you take the reduced denominator, which is x minus 3, and set it not equal to 0, and then you're going to add 3 to both sides. And you'll get x cannot equal 3 for your vertical asymptote. We're going to find the holes of the graph. And you're going to take the x cannot equal 2 from the first step and set it not equal to 0, so it's going to be x plus 2 cannot equal 0. And then you're going to subtract negative 2 from both sides and get x cannot equal negative 2 for your x coordinate of the hole. And to find the y coordinate of the hole, you take negative 2 and plug it in for the x, and you're going to get negative 2 minus 1 over negative 2 minus 3, and that's going to give you 3/5, and that will be your y coordinate of the hole. So your whole will be from -2 to +3/5. So step 4 is to find the horizontal asymptote. And to do this, you first look at the degrees of the exponents in the numerator and denominator. And if they have the same highest exponent, then it's the ratio of the two coefficients. And here, since their highest exponent is x squared and x squared, you take that, and it's just going to give you y equals 1 for your horizontal asymptote. Okay, so to graph it, all you have to do is look at your vertical asymptote, and we know we have that at 3, so you draw a dashed line here, and then a horizontal asymptote at y equals 1. You draw it here, and you fill in your arrows, and you have to remember to draw your hole, so you have a hole from -2 to 3/5.
We're going to solve the problem here, which is 3x squared plus 2x plus 5 over x squared plus 16. To find the domain, you set the bottom half equal to 0. Then you subtract 16 from both sides. Then you get x squared not equaling to -16. Once you square root both sides, you would get x cannot equal to -4. So you get -infinity to -4 union to -infinity to +infinity. The horizontal asymptote, you would first look at the degree of the exponents in the numerator and denominator. If the numerator and denominator have the same highest exponent, then it's a ratio of the two coefficients. And the vertical asymptote, same highest coefficient, there will be no horizontal asymptote. Well guys, we hope that helped.
And if you have any further questions, see us tomorrow during class.
This was Bella.
Cheyenne.
And Keith.